So we can use a histogram to identify outliers. A dot plot can give us similar information. So a dot plot, instead of having these the bins here, and we instead have dots. So here what it's going to show us is every single observational unit that falls here at this 20 hand span is represented as a dot here. Okay, so we have dots instead of bars. You can also identify here the outliers. In a later video, we'll look at something called a bee swarm. This is another type of plot that also shows us this variability and can help us identify outliers. So these aren't the only types of visuals that we can use. Why create a dot plot? Well, we can quickly see the shape. It's helpful with smaller data sets compared to histograms. We can see the range, we can see the max, the min, we can identify the outliers. But unlike histograms, dot plots don't require us to specify what those bins are. It maintains the identity of each observational unit. However, if you have a really large data set, then using a density plot, which we'll talk about in a later video, or histogram is much more relevant. So dot plots allow us to see each individual unit and is better for that small sample than a histogram. Okay, so we can create histograms, we can create dot plots. We'll show you how to use how to create a dot plot in Python in a later video. So one of the challenges with doing all of this in Excel is limited. So if we look at, let's go back in terms of some of the choices for visual representation in Excel, we have bar and column charts. We have line graphs, showing information over time. We have pie charts. We do have tree maps and sunbursts, which we will talk about how to do in Python in a later video. And then with the histograms, and we're going to talk about a box and whisker in just a moment. But you'll notice these are limited in terms of what you can do. Bubbles and scatters we will talk about later. But you can't do all the different types of visualizations like that dot plot. And so we are going to do all those later in Python in subsequent videos. Right now, we're just covering some of the basics and what to look for as you look at your data. We can use our dot plot to compare. So here comparing male and female in terms of hand span to see if there is a difference between the two groups. So we're trying to describe and understand our sample before we make inferences. And here we were looking at, can we make an inference that there is a difference in how far your hand spans depending on if you are male or female. There are other types of visualizations. The stem and leaf, we tend to teach this in intro stats, but there's no good software to make it. It's kind of hard to read. No one really uses it. So I'll just briefly mention that it exists. And so the benefit of this is, again, you can see the individual units. So you can see here there was somebody with a 16.0 centimeter hand span. There were a lot of people with 20.0 because each of these zeros is an observational unit. So you do get the detail of knowing exactly the value for each person in this sample. And you can see the distribution and you can see the outliers. But no one uses stem and leaf. You're using your bee swarm, your dot plots, your histograms, and so we'll stick to how you make those in later in Python and right now in Excel. It does show you the leading and trailing digits. It does show you that distribution. If we were doing this in JUMP, so that's another statistical software, then it will create the stem and leaf for you. So there's lots of different stats softwares, SPSS, SAS, JUMP. In all the videos I'm showing you Excel and I'm showing you Python. Why? Because everybody has Microsoft Office these days and Python is free. So yes, they can do JUMP and R and SPSS and SAS will all do these same statistical analytics stuff that we're talking about here. But it costs a lot of money. So just in case you don't have a copy of that software, we're going with the free and easily accessible. The other thing is as we build into machine learning and AI, then we need more capability than you can do in JUMP. for example. And so Python has that capability. So we're building up to it. First Excel, then we're building up to Python. All right. So we looked at our histograms. We saw the mode, the most common. And again, that histogram, the mode is going to be dependent on what you choose as your bins. The benefit of the mode is that it's less affected by outliers, extreme values, than your mean or your median. The median and the mean are going to be impacted by the outliers. So mean is just the average. Add up all the numbers. That's what this formula says. Add up all the data points and divide by the number. The difference between this formula here and this formula here is that the population mean is everybody. So big N is everyone in the population, and little n is going to be the sample. So our population mean is represented by the Greek symbol mu, mu, and our sample mean is x bar, is the typical notation for this. So our average, because every observational unit is included in this, it is going to be impacted by those outliers. And so it's going to pull the average towards those extreme values. The reason we like means is that we can put it into all kinds of other types of calculations. And so it's mathematically tractable when we do our inferential statistics and our hypothesis testing. We'll throw that mean into the calculation. So it makes it the most commonly used. So if we were to find the mean, for example, let's say we have the score on a quiz for 7 students in a class. Here's their grades, 91, 79, 60, so on. All we have to do is add them together and divide by our sample size of 7, and we would get that that was the average. In comparison, if you were trying to find the median is the middle number. So we would have to take all of these numbers, put them in order, so 60, 79, and then we would figure out which number fell in the middle. The benefit of the median is that it is not as impacted by the outliers because it simply looks at the number of extreme values, not the value of the extreme values. Okay, so it is going to deal better if your data is skewed. And that's why we often look at what is the mean and what is the median. If they are the same, then we have a more symmetric distribution. So let's just go back to this symmetric here. A symmetric distribution, the mean, the median, the mode are all the same number. Okay. If you have skewness like this skewness, because there's an extreme value here up at the top and a higher number, the mode is here, then will come the median, then will be the mean. The mean will be higher than the median will be higher than the mode. Because the mean is going to get pulled over by that high number, the median is going to get pulled by the fact that there is a outlier, and then the mode is here. In comparison, a negative or left skew, the mode will be the highest. Those outliers, those extreme negative numbers, will pull the mean. So we'll have the mode as the highest number, then the median, then the mean. The mean gets pulled the most by the extreme value. The median gets pulled a little by the fact that there is a value that is inconsistent, but not the number itself of what that extreme value is. So we often look at what is the mean, median, and mode relative to each other to help us understand that distribution and whether you have outliers that are skewing the summary that you have. Okay, so if we're back to this example here with the quiz for the 7 students, we'd put them in order, lowest to highest. And so you can see here with 89, there are 3 numbers below it and 3 numbers above it. If we had an outlier, so instead of 60, let's say that number was 10, notice that the median would still be 89. But the average would be much lower because instead of adding 60 here, we'd be adding 10. So you can see how the mean is much more impacted by that outlier or extreme value. So we can summarize the data with mean, median, and mode if we have quantitative data. So here you can see that this data set here has an average of 52 and a median of 44, which comes from sorting it and finding the number in the middle. Notice in this case there are multiple numbers that are the same. Okay, so they each get treated individually when you're looking for that middle number. So 1, 2, 3, 4, 1, 2, 3, 4. We get our middle number right here. Okay. So as I said, the shape is affected by the mean and the median. If it's symmetric, they are equal. If it is right skewed or positively skewed, the mean is larger. The high number is pulling it up. If it's left skewed or negatively skewed, the mean is going to be smaller than the median because it's going to be impacted by those numbers.